This is an ABC podcast.
Hello and welcome to this week's Health Report with me, Norman Swan.
And me, Tegan Taylor.
Today,
could owning a cat increase your risk of cognitive decline?
we take a deep dive into the science behind the Doherty model, which is guiding the National Cabinet out of the pandemic restrictions. Professor Sharon Lewin, the director of the Doherty Institute, will be in to help our understanding of this critical intersection of maths, biology and how we live. But let's start with an issue that will be with us long after the pandemic and probably kills far more people on an annual basis: salt intake. High intakes of salt are linked to raised blood pressure, kidney damage, strokes, heart attacks, and may even raise the risk of Alzheimer's disease and autoimmune diseases such as MS and rheumatoid arthritis by increasing tissue damage through oxidative stress. That's biological rust, if you like, and inflammation. But the problem is we're addicted to salt. But a remarkable trial just published in the New England Journal of Medicine has found that we can reduce our salt intake and save lives without having to fight our addiction necessarily. The co-leader of this clinical trial, carried out in China, was Professor Bruce Neal, the Executive Director of the George Institute for Global Health and Professor of Medicine at the University of New South Wales. Welcome back to the Health Report, Bruce.
Thanks, Norman.
Now, Bruce, when you originally phoned me up and told me about this study, you said it was probably the most important piece of work of your career.
Yep, and I still think that. And the reason I think that is that I think this study has something for everyone. And I mean literally everyone in the world, because almost everyone in the world eats salt and almost everyone in the world eats more salt than they should.
What is the attributable risk of salt, in other words, for premature death? I mean, how much can we blame salt for things?
So it depends a little bit on what you believe, and there has been an element of belief in this, unfortunately. But it's certainly millions of premature deaths each year. Whether it's 1, 2, 3, 4, there remains some debate about.
So tell me about this study and what you did.
So what we did was we wanted to try and answer the question once and for all: if we reduce the amount of salt that people ate, could we reduce clinical events? Because we knew that we could reduce blood pressure before this, but we didn't know whether we could prevent strokes, heart attacks and the like. So what we did was we took 21,000
Sorry,
people.
just to explain, there's been a debate around this, is if you reduce your blood pressure by reducing your salt, some people have alleged you don't get the benefit in terms of heart attack and stroke reduction because there's something different about that blood pressure reduction compared to doing it with drugs or whatever.
Yeah, absolutely. Based on some fairly weak epidemiology, it has to be said, but a debate nonetheless. So to try and answer it, we took 21,000 people from 600 villages in rural China. We went to rural China because it's relatively easy to replace the salt in rural Chinese diet. We gave half of the people a salt substitute, which comprised 75% sodium chloride, so still 75% regular salt, and 25% potassium chloride. And the others continued to use 100% sodium chloride, so just regular salt. And we then followed them for 5 years, and we recorded strokes, heart attacks, and deaths in each of the two groups and compared them. And
you say it's easier because they weren't eating a lot of processed food. So what you see is what you get. It was all added to their cooking and at the table.
Yeah, so at least half of the dietary sodium, and it's the sodium that's the bad bit in salt, that they consume comes from what's sort of sometimes termed discretionary salt, which is salt added for seasoning, when you're cooking, or when you're preserving foods.
What did you find?
So we found that there was a 14% reduction in the risk of stroke, a 13% reduction in the risk of what's termed major adverse cardiovascular events, but is effectively strokes and heart attacks combined, and a 12% reduction in the risk of premature death. And all of these had extremely strong p-values, so 0.006 for stroke and less than 0.001 for the other two outcomes.
Meaning
so
it's highly statistically significant.
Yeah, absolutely. There's no doubt that this was real. And we lowered blood pressure by about 3.3 millimetres of systolic, 3.3 millimetres of mercury.
So that's not far off what you get with a drug.
It's not that far off what you get with a drug, no. And the effects are perhaps not that far off what you get with a drug as well.
And years of life saved, if this was throughout their lives, did you estimate that?
Look, we haven't estimated that actually, but that's something that we do need to estimate. We have estimated, or we're able to make some estimates of what this might mean in terms of lives saved and events averted in China. But we haven't looked at that particular metric yet.
So when you taste this salt that's got, well, first of all, harms, because potassium can do you harm if you have too much potassium in your body.
Yeah, so there's a sort of more theoretical concern about the safety of salt substitutes, and that is exactly that if you eat too much salt substitute, your potassium might go up, and that can make you prone to cardiac arrhythmias and sudden death. And particularly if you've got chronic kidney disease, quite severe chronic kidney disease, you're prone to that, or if you're using other medicines that raise your potassium. So we excluded people by saying, if you've got serious kidney disease, you can't be part of the trial, or if you're using these particular medicines, you can't be part of the trial. We saw no evidence of any increased risk of events caused by hyperkalemia, and we saw no evidence of any increased risk of sudden death either.
And did you measure their blood levels of potassium?
No, we didn't measure blood levels of potassium because this was a very large-scale pragmatic study, and very likely we have missed episodes of biochemical hyperkalemia, but what we almost certainly haven't missed... Yeah, high potassium in the blood. But I think it's unlikely that we've missed sort of clinical events, so serious clinical consequences of hyperkalemia.
Can you taste the difference between regular salt and this potassium diluted salt?
So the particular combination, the 25-75 mix, we chose in large part because we knew it gave a blood pressure lowering effect, but we also knew it tasted very similar to regular salt. If you put a lot of potassium in, it can get a slightly bitter flavour, particularly when you cook with it, although you can add small amounts of selected amino acids as sort of flavour enhancers to control that.
Now, let's bring this home. How generalisable is this to Australia?
Yes, I think that's the million-dollar question. We did it in China because it was a great place to prove the concept. But I think it is widely generalizable. And the reason I think that is that sodium, potassium, blood pressure management, these are bits of physiology that are absolutely constant across the entire human race. Certainly, the magnitude of benefit you might get from salt substitution will vary depending upon how much discretionary salt you're able to easily replace. But I think the principle of reducing sodium, putting more potassium in the diet as an effective way of getting protection against cardiovascular outcomes and death is one that's highly generalizable.
Could you regulate it for processed foods? You insisted the salt they use there, because that's where we get most of our salt from.
Yes, I think it's taken 10 years to do this study. I think it's the next 10 years' work is to find ways to make this happen. And certainly trying to persuade the food industry to add less sodium and to try and retain more of the potassium that is typically in the products before they get processed in the final food products is definitely something we want to do. I think we're also going to need to consider subsidising the cost of salt substitute to the cost of regular salt in lower income settings if we're going to get the benefits. Salt substitute is still pretty cheap, but it is a bit more expensive than salt, and it will be something that will stop people using it if there is a price difference.
So still a job of work to be done. Bruce, thanks for joining us.
Thanks very much, Norman.
Professor Bruce Neal is Executive Director of the George Institute for Global Health, and you're with RN's Health Report. Last week, the COVID modelling from the Doherty Institute, which is what the federal government and the National Cabinet are relying upon, continued to be debated, including on this programme and many other media outlets. It's important because it helps to define a path to more freedom in the next 2 or 3 months, yet may have been misunderstood in terms of what it promises, and like any modelling, has its limitations. So let's stick to the science rather than the politics and take a deeper dive. Professor Sharon Lewin is Director of the Doherty Institute. Welcome back to the Health Report, Sharon.
Pleasure to be here, Norman.
Now, I suppose to start with, any model develops scenarios. It's not predictive of the future on a balance of, and they use a balance of variables. And there are 3 main variables in yours, just to sort of set the scene, because we'll come back to these. Vaccination rates according to age group, public health and social measures, which are really lockdown, masks, and what's called TTIQ, testing, tracing, isolation and quarantine. They're the moving parts, but they're interdependent. Have I got that right?
Absolutely. Perfect.
And the goals, what were the goals you were looking for? Is it suppression? I mean, at various points in the document, it's not clear whether it's suppression or hospital admissions, ICU deaths, or all three. What were the outcomes you were looking for from the model?
Yeah, I'll just start first of all by saying I wasn't direct